I mentioned this theorem called Dirichlet's theorem on primes and arithmetic progressions, which is about finding infinitely many primes in the sequence a plus m, a plus 2m, and so on. So right now I want to write a function, a more advanced function than what we wrote last time, that's related to this idea. So let me call it Dirichlet again. But now instead of just having two inputs, a and m, I'm also going to have a third input, n, which is going to stand for how many primes I want to find. And instead of the output being a single prime, the output's going to be a vector of primes. It's going to be a length n vector that I call v. So first I'm going to initialize v. I'm going to initialize it as an empty vector, a length 0 vector. So I do that like this by writing empty brackets. Now I'm going to use a while loop because I don't know how many steps it's going to take to find these n primes. And what should I say? Let's say while the length of v is less than n. And now what do I want to do? I want to keep looking at a plus m, a plus 2m, and so on. And each time I find a prime, I want to put it at the end of v. So let's not just have v initialized, but let's also have a number x initialized. Okay, I'll initialize it as 0. And then I'm going to say if is prime a plus m times x. So if I find a prime number, then I want to put it at the end of the vector v. So I do v equals v comma a plus m times x. And I don't need an else statement here because if it's not prime, I'm just going to go on to the next one. So maybe you would think the else should be x equals x plus 1, but I want to do that even if I do find a prime. Because even if I do find a prime, I still want to find more primes up until I've found n total. So after this if statement, I'm going to do x equals x plus 1. So let's test it out and see if it works. I'm going to save it as Dirichlet again. And now let's try Dirichlet. And then it's nice that it auto-completes, even though this is a function I wrote to help me remember what the inputs are supposed to look like. So this is why it's always good to name your input vectors something that's meaningful to you, so that when you look at them, you have some intuitive sense of what they represent. So what were we talking about last time? Last time we were talking about 8 and 7. And so instead of just trying to find the first prime in this arithmetic progression, let's try to find 10 primes in this arithmetic progression. And that looks like it's working. So, for example, is 71 of the form 8 plus 7 times x? Okay, well, let's think about it. What's 71 minus 8? It's 63. So yeah, if I do 8 plus 9 times 7, then I get this 71. And if I look at this vector, it really is length 10. And if I wrote my function well enough, I can do it very efficiently. Like there, I quickly found 100 primes in this arithmetic progression.